Hello everyone, I am Mary Swarnalatha, working as assistant professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about definitions of the probability density the power density spectrum and the output of linear system. So first, what is power spectral density, or it is also called as power density spectrum. So a power spectral density or the power density spectrum is a measure of signal's power versus frequency. It means how the power of a signal has been distributed with respect to the frequency is called as power spectral density, or it is also called as the power density spectrum. And mainly the power spectral density is used to characterize the random signal. So random signal nothing but whose behavior cannot be predicted before in future. Then nothing but what? Random signal. So that is the definition of power spectral density. And the power spectral density of a random process x of t has been denoted by S of omega. Next, define cross power spectral density. So power spectral density means we have considered a single signal or a single random process signal x of t. Now what is a cross power spectral density? Nothing but cross power spectral density or cross power density spectrum. So we have to consider two random process or two signals, two different signals x of t and y of t. So consider these are the two random process, and the cross power density spectrum of the two random process is nothing but how the power of the two signals has been distributed with respect to the frequency. In other words, you can say that the cross power spectral density is nothing but the Fourier transform of cross correlation function. So what is the power spectral density of random process x of omega? Nothing but Fourier transform of the autocorrelation function of the random process. And then what is the cross power spectral density of two random process x of t and y of t? That is nothing but Sxy of omega, that is equals to Fourier transform of cross correlation function of the two random process if they are the stationary random process, or else you have to take the Fourier transform of the time average of the correlation functions. Next, define power density spectrum of response. So previously we have seen the power spectral density of a random process x of t, and we have considered two random process x of t and y of t, and then we have seen the definition of the cross power spectral density. Now we have to calculate, we have to define the cross power density spectrum of response. Nothing but we have to apply a random process x of t to an LTI system, and so that it is producing the random process y of t, then nothing but the response to that LTI system is nothing but x of t convolution h of t. So this is in the time domain. Now what you have to calculate? We have to define what? The power density spectrum of response. What is the response of the system? Nothing but y of t. Here the response of the LTI system is nothing but what? Y of t. Now you have to define the power density spectrum of the response of the system. Nothing but Syy of omega is equals to what? Mod of h of omega square into Sx of omega. So this is nothing but the power density spectrum of the response of the system, LTI system. Next one, define spectrum bandwidth. So the spectrum bandwidth, nothing but what is a bandwidth? Nothing but what? The bandwidth of any spectrum is nothing but it is a range of frequencies. So bandwidth is nothing but what? Range of frequencies which have the significant values, and it is also called as what? RMS bandwidth, and it is also called as what? Normalized bandwidth. So for any frequency response with any system, the bandwidth is defined as it is a range of frequencies over which the maximum amplitude falls 1 by root 2 of its maximum value. That is nothing but what? Bandwidth. Next definition is define low pass random process. So low pass, that is nothing but what? The random process has the power spectral density components within the frequency band, nothing but within the lower cutoff frequency or within the passband frequency, that is called as what? Low pass random process. Next one is band pass random process. So what is a band pass random process? If we take a random process of t and the power spectral density of that random process has the components within a band of frequencies, then that random process is called as a band pass random process. Next, define average cross power. So what is average cross power? The average cross power of a wide sense stationary random process x of t and y of t is defined as the cross correlation function at tau equals to 0. So what is average cross power of two random processes x of t and y of t? That is nothing but what? It is a cross correlation function of the two random processes at tau equals to 0. So what is the cross correlation function of two random processes? Nothing but what? Expectation of x of t into y of t plus tau. Now what is pxy? That equals to the cross correlation function at tau equals to 0. Therefore, expectation of x of t into here, substitute tau equals 0, then you can obtain x of t into y of t, which is called as what? The cross power of the two stationary random process x of t and y of t. Next, define Wiener-Khinchin relation. So it is very important theorem. What is the Wiener-Khinchin relation? States that the Wiener-Khinchin relation states that the power density spectrum of wide sense stationary random process is nothing but the Fourier transform of the autocorrelation function. For example, if you take a random process x of t and consider that the random process x of t is a wide sense stationary random process. What is the condition for wide sense stationary random process? For a wide sense stationary random process, it has to satisfy two conditions. The first condition is the mean of the random process is constant for all the values of t, and second condition is nothing but the autocorrelation function of the random process, nothing but rx of t comma t plus tau should be a function of only the time difference. So these are the two conditions for a wide sense stationary random process. So you are considering a random process of t, which is a wide sense stationary, which satisfies the two conditions. Next, what is the Wiener-Khinchin relation? States that the Fourier transform of, therefore the Fourier transform of the autocorrelation function of that random process. What is the autocorrelation of the random process? Rxs of, since you are considering that it is a wide sense stationary random process, it is a function of only the time difference, not depending upon t. It is a function of only the time difference t plus tau minus c, nothing but what? Tau. So therefore, the Fourier transform of the autocorrelation function of the random process is equal to what? The power spectral density of the random process. In the similar manner, if you consider two random process x of t and y of t, then the Fourier transform of the cross correlation function of the two random process is equal to the what? The cross power density spectrum of the two random process x of t and y of t, which is called as what? Wiener-Khinchin relation theorem. Next one, define energy spectral density. So what is the powered spectral density? How the power of the signal has been distributed with respect to the frequency is called as power spectral density. Similarly, how can you define the energy spectral density? How the energy of the signal has been distributed with respect to the frequency is called as the energy density spectrum. Next, define Fourier transform. What is a Fourier transform? The Fourier transform is a mathematical tool which is used to convert a signal from time domain to frequency domain. Or else the Fourier transform of any function is represented by a sum of sinusoidal functions. And the Fourier transform of any signal is equal to what? A sum of these sinusoidal functions, which is represented by the complex exponential. Or else, for example, if you take a signal x of t, and what is the Fourier transform of x of t? That is nothing but x of omega equals to integration minus infinity x of t into e power minus j omega t dt. So this is nothing but what? The Fourier transform of the signal. And here t is a time domain and omega is a frequency domain. Therefore, if we apply Fourier transform, we can convert a signal from time domain to frequency domain. Next, define inverse Fourier transform. What is inverse Fourier transform? The inverse Fourier transform is used to convert a signal from frequency domain to time domain. For example, here x of omega is a frequency domain and time domain nothing but what x of t is. Then what is inverse Fourier transform formula to convert that? So 1 by 2 pi integration minus infinity x of omega into e power j omega t d omega. Therefore, nothing but what? The inverse Fourier transform of a signal is nothing but the sum of or the integration of what? The frequency spectrum of the signal x of omega, which is multiplied by the complex exponential signal, so that you are getting the signal in the time domain. Next, define energy signal. So what is the energy signal? A signal is said to be energy signal if the energy of the signal calculated is a finite value, or the energy of a signal x of t, if it is less than finite, infinite, nothing but it is a finite energy, then the signal is said to be what? An energy signal. So if you calculate the energy of a signal, if we get it is less than infinite, then nothing but what? Energy signal. How do you calculate the energy of a signal x of t? Nothing but what? Integration minus infinity mod of x square of t dt gives the energy of a signal. If that value is less than infinite, then you can say that the given signal is an energy signal. Next, define power signal. What is the power signal? If the signal is having a finite power, then the signal is said to be what? Power signal. So, for example, if you take a signal x of t, then how do you calculate the power of the signal? So, limit t tends to infinity 1 by 2t integration minus t to t mod of x square of t dt. So, this is nothing but what? The power of a signal x of t. So, if that value is less than infinite, then you can say that the signal is a power signal. Next, define convolution. So, the convolution is very important mathematical operation which is used in the signal processing. So, what is a convolution? Nothing but a convolution is nothing but a mathematical operation on two functions. For convolution, how many functions are required? Two functions which produces a third function. So, it shows how the shape of one is modified by the other signal. So, for example, if you consider two signals x of t and y of t, then let us say x of t and h of t. Then what is the convolution of the two signals has been represented by x of t convolution h of t. The star mark here represents a convolution operation which is what? Y of t. Then what is the formula? Integration minus infinity x of tau into h of t minus tau d tau, that gives the convolution of two signals. Therefore, the convolution can be defined as what? It is a mathematical operations which is performed on two functions to produce the third function, which express how the shape of one signal is modified by the other. That is nothing but convolution. Next, what is the average power? So, how can you define the average power? The average power of a signal is defined as the power dissipated by a signal voltage x of t which is applied across 1 ohm resistor. That is nothing but what? Average power. Next, define Password's theorem. What is the Password's theorem? The Password's theorem defines the power of the signal in terms of what? Fourier series coefficients. Then it is nothing but what? Password's theorem. The Password's theorem defines what? The power of the signal. What is the power of the signal? Previously I have seen the power of any signal x of t is nothing but limit t tends to infinity integration minus 1 by 2t integration minus t to t mod of x square of t dt. Is nothing but what? The power of the signal. So if it is defined in terms of Fourier series coefficients, then the theorem is called as what? Pascal's theorem. Next, define relation between the power spectral densities of the input process and the output process of an LTA system. So what is that? We have to define the power spectral density of the input process and output process of an LTA system. For example, consider an LTA system. What is an LTA system? Linear time unit system. If a system is satisfying both the linearity property and time unit property, then the system is called as what? LTA system. What is a linearity property? If the weighted sum of responses is equal to sum of its weighted responses, it is called as what? Linear system. Or as can also define as what? If a system is satisfying both the homogeneity and superposition principle, then it is nothing but what? Linear system. What is a time invariant system? A system is said to be time invariant if its input-output characteristics does not change with the shift in time. That is nothing but time invariant system. If the system is satisfying both these properties, it is called as what? Linear time invariant system. Therefore, consider a linear time invariant system whose for that system I am applying a random process input as x of t so that I am getting the output or response as y of t. Now, here what you have to define? The power spectral density of relation between the power spectral density of the input random process. Then what is the input random process here? X of t. Then what is power spectral density here? S xs of omega. And here what is output? Y of t. Then what is this power spectral density? S y of omega. Then the power spectral density, the output power spectral density is the product of what? The input power spectral density and the square of the transfer function. Nothing but what is Sy of omega is equals to Sx of omega into mod of h of omega square. Here what is h of omega, which is called as a transfer function, that equals to what? Y of omega by x of omega. What is y of omega? The Fourier transform of the output random process. And what is x of omega? The Fourier transform of the input random process x of t. Next, define the power at the output of the LTA system. So what is the power at the output of the LTA system? Nothing but the power at the output of the LTA system is nothing but the area enclosed by the output power spectral density. Nothing but what? What is the power of the, for example, this is the LTA system. For that, the input, let us say x of t, and its output is y of t. And its transfer function, let us say h of omega. Then the power of the output of the random process. Nothing but here, what is output here? Y of t. Then the power at the output of the LTA system is equals to what? The area enclosed by the output power spectral density. Then what is the output power spectral density? Nothing but Sy of omega. What is area? Integration minus infinity Sy of omega d omega, which is divided by the 1 by 2 pi. So this is called as what? The area enclosed by the output power spectral density is called as what? The power of that output power of that LTA system. Next, define the properties of power spectral density. So what is the first property? Already we have seen that the area under the power spectral density is equal to what? The average power of the signal. That is the first property. And what is the second property? The autocorrelation function and the power spectral density both form a Fourier transform pair. This already we have seen. Nothing but Wiener-Kinchen relation. And now just we have seen the area under power spectral density, nothing but what? The average power of that signal. So these are the two properties of the power spectral density. Next, define cross correlation function of the output random process. So what is a cross correlation function of the output random process? Is nothing but what? What is output random process? If you consider the LTA system, if the input is x of t and the output of that system is y of t, then what is y of t? Nothing but what is x of t convolution h of t. That is nothing but what? Output of that random process. Next, define linear system. What is a linear system? If the system is satisfying both superposition and homogeneity principle, it is called as what? Linear system. So for example, if you consider the input as x of t, x1 of t and x2 of t, then the response of weighted sum of inputs, nothing but here t nothing but transformation operation. By performing some operation input, you are getting the output. Therefore, the response of weighted sum of inputs is equal to the sum of its weighted responses. Is equals to what? Sum of its weighted responses. Then the system is called as what? Linear system. So it satisfies both homogeneity and superposition principle. Next, what is a time invariant system? A system is said to be time invariant if its input-output characteristics does not vary with the change in time. Then it is called as what? Time invariant system. For example, if x of t is the input and y of t is the output. So x of t here is what? Input and y of t is the output. Then if its input-output characteristics should not change with time, nothing but delay the input and then calculate the response of the system. Then what you're getting here, let us say y of t comma k. So this is the response of the system due to the delayed input. And then delay the response by k is nothing but y of t minus k. If these two are equals, then nothing but y of t comma k is equals to y of t minus k. What is y of t comma k? It is a response due to the delayed input. Then what is y of t minus k? The delayed output response. If these two are equal, then system is said to be what? Time invariant system. Next, to define white noise. So what is a white noise? A zero mean wide sense stationary and noise random process n of t is said to be white noise if the power density spectrum is constant at all the frequencies. Then that noise is called as white noise. For example, here n of t is a white noise. Then what is the power density spectrum of that white noise, which is represented by what? Sn of omega. So which is some constant, let us say alpha, for all the frequencies. For all the frequencies, then the noise is called as what? White noise. So what is Sn of omega? Nothing but what? It is constant for all the frequencies. Then that type of noise is called as what? White noise. Next, define properties of white noise. So white noise has following the properties. The first property states that the autocorrelation function of and white noise is an impulse function. The autocorrelation function of the white noise is what? An impulse function of amplitude S0. And second one, the power density spectrum is constant at all the frequencies. For white noise, the autocorrelation function is an impulse function. And second one is power density spectrum is constant for all the frequencies. And third property is it is physically unrealizable because it possesses infinite average power. That's why it is not the power signal. Therefore, these are the properties of what? White noise. Next, define band limited white noise. So, a band limited, nothing but a noise having non-zero and constant power spectral density over a finite frequency band, and zero outside this frequency band is called as what? Band limited white noise. So, band limited, nothing but what is a white noise? Actually, nothing but whose power spectral density is constant at all the frequencies. But what is a band limited? So, band limited, nothing but what? Which is constant only some particular frequencies from omega 1 to omega 2. Outside of this range, it is 0. So, it is constant what? Only within this band of frequencies. Then, that type of white noise is nothing but band limited white noise. Next, define color noise. So, a random noise which is not white, then nothing but color noise. What is not white? What is white noise? Whose power spectral density is constant at all the frequencies. If the power spectral density of any noise is not constant with respect to frequency, then the type of noise is nothing but what? Color noise. Thank you. So today we have seen the definitions of the power spectral density of a random process and the cross power spectral density, the average power and the cross power, and then we have seen the different types of noises of the system. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.